Hi there once again, and welcome to another Expresso mechanic tutorial. And this is going to be episode 19 in the series Python Bytes. I was recently approached by Sagan Manandhar, I believe is how you may pronounce your name, but if I've got that wrong, I do apologise. But he asked me if I could do a more in-depth study of the Python RangeMapper. And I'm more than happy to do so, and that's what we're going to be looking at here. We're actually going to be doing a comparison between the Expresso RangeMapper and the Python version. That's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. I've brought a couple of text objects in here, but these are completely optional. They're just for illustrative purposes, so you don't need to bother with these yourselves. What we do need, though, is a cube. We'll bring one of those in, make it 20 by 20 by 20. I will add a fillet, you don't have to, but I'll put a 1 centimetre fillet on there. Okay, great. So we've got a cube. We also need a copy of it, so we'll command drag to copy, and we've got a second one. The second one I'm actually going to drop into a cloner, so I'll bring one of those in, drop this in here, and in our cloner we can make it a linear cloner, and we just want a count of 1, and that's fine. And then we can just move this, well, in fact we'll leave that one there, we'll move the original cube because that's going to be the Expresso cube. Just put that under there. Okay, fantastic. The next thing that we need is to select the cloner and get a hold of a Python effector. So we'll get one of those. Just grab a hold of the effector, drop it into the scene, and we can see that it's already doing something because our cloner was selected. The next thing to do is to set up the Expresso tag on a null, so we'll bring one of those in, drop it down here, call it Expresso, and give it the Expresso tag, and we've got our window. We'll just bring that up there and just leave it there for a second. The next step for us is to select this Python effector and add some user data, and I just want one user data, so I'm going to call it move. And it will be a float. The interface will be a float slider. We want a real value for the unit. Steps of, I'm going to say 0.1. That will be fine for us. And we'll go from 0 to 100 and clamp those values. And that's fine. We've got that. We can hit OK. Actually, before I do that, there is one other thing that I will do. I'm going to add some more data. This will be a spline, because we will require this a little bit later, so we might as well do it now. It will be a spline, so we'll select spline from our data type menu, and then we can just set this up. If we twirl it open, we want 3 points, so we'll set those just roughly. The first point here, 0.25 is fine for that, for our right tangent. Our left tangent here needs to be minus 0.25, and our center point here, what we want to do is set the x value to 0.5, the y value to 1, and then we can just say minus 0.25, and that sorts that out, and we've got a bell curve. That's what we need. We can then hit OK, and we've got our data ready to use. Fantastic. Let's move on from here and take a look at the Expresso. The first thing that we can do is bring in the Python effector, and we want its user data, so we want move. We'll then bring in a time node, because I'll be using this later on in the tutorial. As per usual, I will add a frame port and I will get rid of the time port, because the frames are going to be important. And then we simply need our range mapper, so we'll bring that in now, drop it here, and we can plumb the output of our Python here into the input. And then finally we just need our cube and drag that one in, and we'll use our position Y. So transform position, position Y. Now obviously the range mapper is not currently set up correctly, and we've got to do that next. So let's click on the range mapper and get it set basically to what we need it to be. Now, as we're going to be using move, we know that that range is from 0 to 100. So we can say our input upper will be 100. And then our output range, I'm going to go from 0 to 120. And we will, of course, use spline. And we need to set the spline up in here. We want to replicate the spline that we created in our Python effectors user data. So we'll do that now. Twirl it open. Again, we've got, where are we? 0.25 here. That's perfectly fine. This needs to be minus 0.25. And then the center point, as before, 0.5 for the X, 1 for the Y, and minus 0.25. And those two match. Great. So we've got everything set up thus far. Now, if we select our Python generator, our Python effector, and we move this slider, we can see that it is doing its job. We're getting our data mapped and our cube is moving as we would expect it to. Okay, so that's perfectly good. It's doing what we need it to. The next thing to do is work with the Python here and get that set up exactly the same. So that's our next task. Before we do that though, I will select the range mapper and open a second window for its attributes. And I'm going to dock this here and just bring this back, and I'll also rearrange things here to just get that over there and just move this slightly back. Well, not actually, I won't. I'll leave it there because I want to see the whole curve. The next thing to do then is work with the Python. Let's bring this open, and I'll just do it in the editor, and I'll dock this here and then make that window a little bit smaller so that we can see everything. Okay, let's get working with our Python. Now the first thing that we need to do is take full control. So we'll click down here and get rid of the loop, as we always do. Just get rid of that for loop and hit execute, and we're ready to go. The first thing that we need to do is bring in our user data down here. So we will say move is equal to drag move in. As per usual, it's in the wrong place. Let's just select it and paste it in to the correct place, and then we can get rid of this and just put op in there. Spline is equal to, and you guessed it, we'll drag in spline, drop it in, it'll be in the wrong place. Drop that in there and put op in front of that. So we've got our user data in, and that's ready for us to use a little bit later. I'll also add the frame variable because I've got my time node with the frame here, and this is going to be the Python equivalent. So frame is equal to dot get time, open close, dot get frame, open doc, dot get fps, open double close. Fantastic. So we've got that frame variable, and we can get our frames from the timeline. We can now move on and think about where we're going from here. What we can actually do is bring in the range mapper. Now, before we go there, let's just do some work here. I'm just going to close this down, shrink this down for a minute, and get rid of that. And I've got the SDK here. Now, the actual range mapper is stored in the module c4d.utils. So if we click on that, we'll find it in here. Let's see where it is. We just got to find it. There's a lot of things in here, but it's It's not too difficult to find, or at least it shouldn't be, he says. Let's have a look, see where it is. But it's worth having a look at it because it's one of those things where you do need to have a look. Here it is, RangeMap. That's what we've got. So let's click on there. So we can see that this takes a value. It needs a minimum input, a maximum input, a minimum output, and a maximum output. It's also got a clamp value and a curve. Okay. Well, that does make it quite similar to the Expresso version, because we can see if we bring our Cinema 4D back, we've got the input lower, the input upper, output lower, output upper. The curve, as we mentioned in there, is actually referring to the spline. Okay, so all of those things are in there. And of course, the value is just the value that you plumb in initially. It's not here now because, of course, we're using move at the moment. We've got that plumbed into the input, but if we took that away, we'd see that we'd have a 0 at the input. So yes, there are a number of similarities between the RangeMapper from Expresso and of course the Python version. They are quite similar, but they're not exactly the same. There's less functionality available to us with the Python version because we don't have the modulo, we don't have the reverse, and the use spline, of course, is there, but it's optional. Clamp lower and upper, they are technically there, but they're not separate. So you've only got a limited amount of control, and there's an anomaly with that we will be seeing later on. So yeah, that's, as I say, if you need to find out any information about the RangeMapper, this is where you go. You just go into your utils RangeMap, and there's even a little bit of sample code there, which does give you some help. So do bear that in mind. Okay, let's get back to Cinema and carry on from here. Let's get the RangeMapper code in. So we can say range_mapper is equal to, and it will be c4d.utils, because as we say, that's the module that it's stored in, .range map, and then it will be brackets, and we're using move as the input range, so, or the input value I should say, so move, and then it will be 0, 100, because of course they are the values associated with move. We know that it ranges from 0 to 100. And then the output will make the same as we did with the Expresso. So it will be 0, 120. We deal with the clamp next. Now, let's say true in there for now. And then the final part of this is to put spline in here so that we do actually get this bell curve, or rather this bell curve here, but they're both identical. So that's our RangeMapper's code complete. We then need basically to convert the matrix for our clone here down to a vector and then to a real value. So we can say x is equal to mar bracket 0, because of course we've only got the one clone and we want the matrix for that clone, or the matrix array for that clone. And then it will be dot, and we want the offset vector, so dot off. That's the vector that we're dealing with, and we need to convert that vector to a real value, and we want the x first. And then it's a case of copying and pasting and setting up the y and the z. So the y, now the y won't be dot off, that will be, it will actually be, in fact, it won't be this at all, it will be y is equal to RangeMapper. That's what needs to be in there. We need to spell it correctly. RangeMapper. Okay, so that's y dealt with. And then the z is actually going to be z is equal to mar bracket 0 dot off dot z. And that completes that vector to reals conversion. We can then say, well, in fact, we need to convert everything back to a vector. So it will be mar brackets z, or bracket 0, I beg your pardon, dot off is equal to, and it will be c4d dot vector, and then it will simply be brackets x comma y comma z, and that completes it. That's as much as we need to do at this moment in time. Now, if we start working with move, we should find that it will actually work here. So let's do that and see what happens. And sure enough, it does. And we've got the same result replicated. So we're doing exactly the same here as we're doing in here with this range mapper. We've literally created this situation in Python. So quite simple. But let's start looking at some of the other features of our range mapper here. Now, for a start, we've got two data types. You should be able to work with vectors within a range mapper. In fact, you certainly can. You've got to set things up slightly differently, of course, because you'll have to use c4d.vector, and then the xyz values will have to be in there. That's the kind of thing you're going to have to put in there to use vectors. The input range at the moment is user defined. Certainly we can work with degrees and radians. That's not a problem. Obviously these are self-explanatory. You just put 0 to 1 as opposed to 100. We've got 0 to 100 in there at the moment, so we've got that in there. So certainly you can work with these other types of input ranges. I mean, again, if we were to return to, so look, go back to our SDK here. If we go back up here to the top in our utils, we've got degrees to radians, we've got radians to degrees. So if you want to work with degrees and radians, these are the ones you're going to need to be working with. You would have to say c4d.utils, degrees to radians, and then put a value in there in degrees, and it would then be converted to radians. And the reverse would be true with radians to degrees. So that's the way you would go about using those two. So yeah, it's available to you. You can do these other things, these other types of inputs and output ranges. Now the clamp upper and lower, as I say, all we've got here is true. We don't have the option to say, I want to clamp the lower, I want to clamp the upper. It's just true, so you clamp both of them. Okay, that's how that's working. The modulo, we definitely haven't got. I mean, if we switch on the modulo here, and what we'll do is lower this value so that we'll say it's 50. What we'll now get is the Expresso. If we work with our move here, if we just select move, if we work with this, we can see that it works twice. So we go up once, go back down again, and then we go up and down again, because we've only got 50 in there, but move ranges from 0 to 100. So with a modulo, as soon as we hit 50, it goes back to 0 again, and then starts climbing back up to 50 and then back down to 0. So we're getting that modulo value in there. Now, we don't have the option, and we've got a pile up now because I've switched the modulo off, and that causes this to do strange things. So you've got to bear that in mind. The Expresso range mapper will start to do strange things if you don't have the correct input range in there and you're not using the modulo. So if we put that back to 100 and then we move this, we can see that it's fine again. Okay, but do bear that in mind. If you've got 50 in there, make sure you switch on the modulo, and then everything will work perfectly well. Alternatively though, you can switch off the modulo and clamp the upper, and you'll get a usable result. So that's the other way to deal with that particular situation. We'll worry about the clamp a little bit later though. For the moment, we'll replicate this modulo in our range mapper. And the way we do that, obviously we can't do it within the range mapper, we've discussed that. So we have to code it. The way we do it is to say mod move, at least that's what I'm going to call it, mod move for modulo move. And we'll say is equal to, and it will be, on this occasion, move and percentage sign for modulo 50. And then in here, we can replace move with mod move. And now we should get the same result. And sure enough, we do. That's working fine. So that's how you deal with coding a modulo to match what we've got in our Expresso RangeMapper. Fantastic. As I said, we can look at the clamping. If we switch off the modulo and check the clamp here, we know that that will solve any problems that we might get. That's working okay. And it's all doing what it should be doing, except that we don't get the double movement. We just get a single movement. And that's exactly what we should get, because as soon as we get to 50, it stops, and that's correct. That's absolutely correct. Let's see if we can replicate this in Python. For a start, we'll go back to move as opposed to mod move, because we don't want the modulo at the moment. And we'll set this to true. And let's see if this actually works. Let's see what happens. So when we get above 50, yeah, it stops. It's doing exactly the right thing. Okay, so we've got it that far. The one thing we haven't looked at yet in here is this reverse checkbox. Now let's just check that. And straight away you can see the cube jumps to 120, because that's what we've done. It's the output range that's been reversed. So we're going from 120 to 0 now. In order to achieve that here, we simply reverse the figures, because we've no option to do anything else. So let's see what happens when we do that. So we're going from 120 to 0, which is exactly what we've set up in here. Of course, if you wish to, you don't have to use the checkbox. You can do the same as I've done down here in here, but it's just quicker to just switch that on. Okay, let's see what move does now. So if we move our slider, oh dear, nothing's happening. So why might that be? Well, there's an anomaly, and I think actually it's a bug within this line of code. And I think Maxon need to take a look at this, because what we need to do is set this to false. And now if we move our slider, we can see that instantly the cube actually jumped from 0 to 120 and then started to behave exactly as it should. You can see it's working now. Once we get above 50, it stays there. And yet the clamp is false. Very, very strange. And that's just because we've had to reverse these values. I think that's a bug. It certainly isn't supposed to work this way. I'm convinced of that. Very, very strange. But something that you need to bear in mind if you're working with the RangeMapper. If you find that you set this to true and things don't work out for you, then try setting it to false and see if that makes a difference. As I say, when you're going from a high value to a low value, that's when you seem to get the problem. And also, if you start using negative values, I've found that it's been a problem there. So, bear this in mind when you're using the RangeMapper in Python. Right, well, let's move on from here. So we've looked at the reverse, and we've found that there's a bit of an anomaly within the Python there. The next thing we need to do is just work with the time node that we've got here and plumb the output of that into the RangeMapper. What we'll do is uncheck the clamp, and we'll bring the modulo back. And if we just play our timeline, we can see that we're getting a nice repeat there, which is exactly what we should get. So let's replicate this here. For a start, we'll need to use mod frame, or mod, it would be mod move, but we'll have to say mod move is equal to frame. That's the first thing we'll need to say. So frame in there. And then we can bring mod move back into here. We'll leave the clamp as false. We'll take this back to 0 and then go to 120. And let's see if that actually does anything. So we're back at 0, so it certainly worked that far. Let's play. And there you go. It's working, and it's doing exactly what it should do. And that brings us more or less to the end of this tutorial, because I've shown you everything, well, pretty much everything actually, with regard to the Python RangeMapper in comparison to the Expresso RangeMapper. And as always, I really hope that this video has been of value to you and it's given you some ideas for things that you may be able to use within your own projects. And if you have enjoyed the video, please give it a like. And if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one. So I'll see you very soon on the next tutorial.